In the previous class, we learned about the image formation by the concave mirror. Image formation by the concave mirror and the ray diagrams of the concave mirror at different positions of the object. Okay, in this class, we are going to learn the ray diagrams of convex mirror. Ray diagrams of convex mirror. First, the representative rays and the ray diagram of the convex mirror when the object is placed in front of the convex mirror where the image will be formed. Okay, so let us start with the representative rays in case of convex mirror. Okay, so first ray 1, as in the case of as we have already learned in the case of concave mirror, in convex mirror also let us take the ray 1, which is the ray which is parallel to the principal axis. A ray which is passing parallel to the principal axis. Let us take a ray which is passing parallel to the principal axis. This is the incident ray in case of this convex mirror. And after reflection, as we already know that when the rays gets incident on convex mirror, they diverge. They do not converge, they diverge from the mirror. As now here also the ray will be diverged. The ray will be diverged. Yes. So here when we represent, it is a pole and focus, center of curvature. Yes, the ray is diverged here. Yes, the ray is diverged after reflection. But when you observe this reflected ray from there, when you observe this reflected ray from here, then it looks like, it appears like that it is coming from the focus. It appears that it is coming from the focus. Yes, now concentrate here clearly, properly. Here these are the real rays. It is the real ray, incident ray, and after reflection it is getting back, that is it is diverged. That is also the real ray. But here this is the virtual ray. It is the virtual ray. It is not real. Just we are extrapolating the reflected ray. Yes, that is appearing to pass through the focus. Yes. So now the first ray 1 is a ray 1 or the representative ray 1 in case of convex mirror. When the parallel ray gets incident on the convex mirror, after reflection, the ray seems to be coming from, the ray appears to be coming from focus, or the ray appears to be passing through the focus. So this is the ray 1 in case of convex mirror. So in case of concave mirror, what we have seen, when a ray is parallel to the principal axis, after reflection it passes through the focus. That is a real ray. But here the ray is diverged, and when you extrapolate the extended reflected ray, that appears to pass through the focus. Right? Here we are including one thing, that the ray appears to pass through. Yes, it appears to pass through the focus. Yes. Next, ray 2. So what is the first ray? When a ray parallel to the principal axis is it's getting incident on the convex mirror, after reflection it appears to pass through the focus. Next, ray 2. Ray 2. Here, what is the ray 2? We have taken the converse rule to the first rule, or the converse ray to the first ray. So what is that? Here let us take the convex mirror, pole, principal axis, focus, center of curvature. Yes, the ray which is appearing to pass through the focus, a ray which is appearing to pass through the focus. This ray is appearing to pass through the focus. So this is incident ray. But when it gets reflected here, when it gets incident here, then after it will be reflected. So in the reflection process, it passes parallel to the principal axis. A ray which is appearing to pass through the focus, after reflection it passes parallel to the principal axis. Yes, so it is not the, this is up to here it is the real ray. Yes, from here to here it is virtual ray. It is appearing to pass through the focus. After reflection it passes parallel to the principal axis. So that is a ray 2. And next ray 3. Ray 3, in the same manner, pole, focus, center of curvature. Now let us take the ray which is appearing to pass through the center of curvature. A ray which is appearing to pass through the center of curvature. Yes, so let us take a ray which is appearing to pass through center of curvature. That means here it is the incident ray, that when it gets incident here, then it will be reflected back from here itself. Yes, so that retraces the same path, right? So that retraces the same path, that reverses its path. So then when you extrapolate this ray, it appears to pass through the center of curvature, right? So this is the ray 3. So ray 1, ray 2 and ray 3. Ray 1 is when the parallel ray gets incident on the convex mirror, it diverges. It diverges. When you extrapolate the divergent ray, it appears to pass through the focus. Yes, this is a rule 1. And rule 2 or ray 2. Yes, so when the ray is parallel, when the ray is appearing to pass through the focus, after reflection, it passes parallel to the principal axis. Then ray 3, a ray which is appearing to pass through the center of curvature, after reflection, it retraces the same path. That's it about the 3 rules or 3 representative rays of convex mirror. Yes, so let us draw the ray diagram based on these 3 representative rays. So let us take the convex mirror and let us place an object at any place in front of a convex mirror. So this is the reflecting surface, non-reflecting surface. So object O dash or AB also you can take, there is no problem in that. So here it is a pole, focus, center of curvature. So let us take the first ray, a ray which is parallel to the principal axis. This is ray 1. Ray 1. After reflection, it will be diverged. The ray will be diverged, and when you extrapolate this ray, it appears to pass through the focus. We have taken the parallel ray, which is parallel to the principal axis. Then after reflection, the ray is diverged. When you extrapolate this or extend this reflected ray, then it is appearing to pass through the focus. Yes, so it is the virtual ray we have taken. Next, another ray, a ray which is appearing to pass through the center of curvature. A ray which is appearing to pass through the center of curvature. Yes, it retraces the same path. And when you observe these 2 virtual rays, when you observe these 2 extrapolated rays or extended rays, these 2 rays are meeting at this point. And this will be the image point, that is I dash. I dash. O dash is the object and I dash is the image. And what is the nature of image and what are the properties of image? So here object is like this and the image also like this. Erect image, that means same type of image. So it is erect image, and the image is formed inside the mirror or on the screen. The image is formed inside the mirror, it is not formed on the screen, right? So the image is formed inside the mirror, that is why it is a virtual image. Yes, so here what is the nature of image or properties of the image? That is first one, virtual, because it is formed inside the mirror, it cannot be taken on screen, that is why it is virtual image. Virtual, erected or erect means straight image, it's not inverted, is straight image. Yes, virtual, erect. Is it diminished image or enlarged image? The image is smaller than the object or larger than the object or same sized as the object. It is smaller size. It is a diminished image. And where it is formed? It is formed inside the mirror. So these are the properties of the image formed by the convex mirror. Wherever you place the object in front of a convex mirror, this type of image will be formed. The properties of the image will be like this. That means virtual image will be formed, erect image will be formed, diminished image, and the image will be formed inside the mirror. Yes, and where it will be formed? Between focus and pole. Between focus and pole inside the mirror. Yes, it will not be formed here and here. Yes, it forms nearer to the mirror, wherever the object is there, but the image distance is this much itself. Yes, so object distance, it is irrespective of the object distance, image distance will be like this. Image distance is always less than the object distance in case of a convex mirror. That is why these convex mirrors are always used in rear view mirrors in automobiles, like side mirrors of bikes and side mirrors of cars, in all these, to observe the vehicles which are coming back. Yes, so to observe like that, so these convex mirrors are used. So far we have discussed about that when the object is placed in case of when the object is placed in front of a convex mirror or concave mirror, based on the object positions where the images will be formed, and what are the properties of those images. So that we have learned with the first one with the lab activity, and next with the ray diagrams. Now if a focal length of a lens is given and image distance is given, then they have asked to find out the object distance. And next, in a simple case, a focal length of a lens is given as 5 centimeters and object distance u is given as 15 centimeters, and they asked to calculate what is the image distance and where the image will be formed when an object is placed at 15 centimeters away from the concave mirror or convex mirror. Yes, and its focal length is 5 centimeters and where the image will be formed. Yes, ippadi varaku just manam ray diagrams tho plus ల్యాబ్ యాక్టివిటీతో, సో వీటి ద్వారా మనం ఆబ్జెక్ట్ ని ఎక్కడ పెడితే ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది, కాన్వెక్స్ మిర్రర్ లో కానీ కాన్కేవ్ మిర్రర్ లో కానీ, సో ఎక్కడ ఆబ్జెక్ట్ పెడితే ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది అనేది తెలుసుకున్నాం. బట్ ఇప్పుడు ఫోకల్ లెంత్ వాల్యూస్ ఇస్తారు. సో వాల్యూస్ ఇచ్చేసి ఫోకల్ లెంత్ ఇచ్చారు, ఆబ్జెక్ట్ డిస్టెన్స్ ఇచ్చారు, ఇమేజ్ ఎక్కడ ఫామ్ అవుతుంది కనుక్కోమన్నారు. Yes, further what do we need? We need a relation among those three. Yes, what are those three? Focal length, object distance and image distance. Focal length is represented by small f, right? And object distance u and image distance v. Yes, so if we know the relation among these three, then we can calculate the image distance or object distance or focal length, whatever. So if two are given, another one we can calculate, and we can estimate the image position based on the object distance and focal length. Right? So what is the relation among these three? Okay, so here let us see the relation 1 by f equals to 1 by v plus 1 by u. So this is the relation among focal length, object distance and image distance.